So yesterday I did this end-to-end Kaggle submission pipeline from reading the data set to model training. And in during the training, that's where I had gotten stuck. So I did the forward pass, taking a single batch and passing it through model and seeing how wrong the model is for that specific batch. I did that. And then we calculate the error, and according to with respect to the error, we adjust models where internal parameters to get it close to the answer. So for that error calculation and then accordingly updating the gradients, that's where I got into problem yesterday. So if you check the yesterday's codes, this thing, if you let me check file history here. So yesterday I was doing the training loop. I did this. I read the data in from this dataset path like this. Maybe let me zoom in. Mm, So I read it from here, this folder, image folder. Yesterday I had the code like that, okay? And then simple model, and then I was trying to do model.fit, and it gave me an error. So in the code which seemed good, there were four bugs which took almost entire day. And they were very interesting bugs, okay? It's just insane. So let me start with the first bug and how sneaky it was. So first one is this image path. So the first bug I had was the dataset path which I was reading from image folder as a folder. This people generally don't agree. I mean, there is a standard format of how training data should be. Okay, we have the name of the data set. So train for training folder, test for testing data, and then validation folder for validation data. And inside the training ones, whatever is the class, we have its separate folder, and all the images belonging to that class are present there. So that is how the format is. Okay. So dataset path, and these are the standard ways, you read from the image folder. So in PyTorch, it is also similar, same function. So if you have PyTorch, Torch Vision datasets, and it also has image folder. And similarly, TensorFlow also has tf.keras.utils image dataset. This is the path for Keras. Okay. So going back here, I did this, okay, and I executed. And I did this quite a lot yesterday, okay, but this didn't register to me how and what it is reading. So the first bug was it has found 20,000 files belonging to two classes. One class is training and another class is for validation, something like that. So so all of the things, it has treated train as a class and test as a class, and it has split them into two sections. So not what we want. We have 120 dog types species, and we want to read that in the syntax here, because I gave the root path, and it actually read it like this. And I read it immediately doesn't register that it is not according to how we want, and I just move forward. So this bug crept in. I started debugging. It led to a lot of to and fro, and I didn't even realize and find this problem. So solution, give the appropriate path. So everything is present in this train directory. So I'm giving this train dataset path. And from that dataset, I am doing the split further only under this train folder. So when I do this and then I read the output, then you can see everything is correct now. There are 120 classes now. What problem we have here? So this was first bug. It's kind of like insane that this is how it would work, but you got to pay attention. I thought it was fine, but this I also marked it as done yesterday, but it was not. There was a bug here. Then the second bug we had was this thing called as label mode. So this, the default value of this, you can actually check in the documentation. Always have the documentation, and in the documentation you can check the default values. And TensorFlow for actually needs more access to documentation because it tries to give you fancy stuff. And if you don't check, if you're not accurate, it is gonna give you an error and it will be impossible to debug it if you don't, consult it thoroughly. PyTorch is easier because limited functions, limited ways things could go wrong. So net as a whole, it works out better. So here, if you check, first is directory, then labels. By default, it kind of like takes from the folders. So that's why we have inferred labels. You can find the details here. And then you have label mode. By default, it is int. So anything which is equal to something, whatever value, that is what is taken as default. So when we read this data set like this, what happens is the output is in the format of a single class ID. Okay, how? Let me show you an example. Immediately we can see. So training data set, this, and in this data set, if I want to get the zeroth element, TensorFlow doesn't allow us that, whereas the same thing PyTorch would have. So there is another way to do it. This is iter of training data set, and of that iterator, I just want to take one example out of it. Okay, so if I do this, this is what I get. So what do we have here? We have one example, and it's like x comma y is equal to this. If I do it like this, and then it's gonna have x dot shape and y dot shape. This is what we have here. So when we do it as label mode equal to categorical, and here batch size is used as 32. That's why for even a single instance, we are getting 32 examples. So let me just change it to 1. Okay. So execute this, do this again and print. So now you see this one corresponds for there is only a single example. And here the y value is of 120 length, which is same as the number of classes we are trying to predict, 120 dog species. So you see, when I see label mode as categorical, it gives me a vector. It gives me a vector. Y is as a single vector. It is one hot encoded. And when we put label mode as categorical, the loss function which we have to use, it has to be used as categorical cross entropy. If we put this label mode as int, then what happens is, let's see, we get a single number. So this number tells me which out of 120 it is. So it's gonna be from 0 to 120. Each class is gonna have one number which is incremental. Whereas in categorical, we had vector category. So when we have label mode as categorical, we use loss function as categorical cross entropy. And when we have it as int, we have to use sparse categorical cross entropy. This is the thing here. And where did I find it? I found it in documentation and spending a lot of time, debugging it. Because when but default value was int. So in the code, if you check, the default value is int. So then, to get it working, I had to write my own training function. So that's what I spent time debugging yesterday. So I wrote my own function here, doing epochs, doing gradient tape, and all of this internal way of doing things in TensorFlow. I spent all that just so that, eventually the error was originated from here, because I was the output which I was in loss, which I was trying to calculate. It expected a vector and I was giving an integer. So all that thing simply because I did not include this labels equal to categorical. So this was another bug. Okay. And I think it is quite possible that it is a very common error because it's counterintuitive. Whereas label mode is categorical, which I have given it to be correct. Okay. So this was the second bug. And then the third bug is it has these default variables. Batch size. If we don't specify anything, it takes batch size as 32. So what I did was to test how my model is doing. I created a batch of a single example. and I was testing it, trying to test it here. I thought, I haven't specified a batch size, it's going to give me a single thing, but no, this number was just a surprise. I had to keep it in mind. So that was third problem. Not that big of a bug, but first two really big bugs. And third, if you want to use this validation split to split the data set, one for training and then one for validating how good our training is, this validation split is option I decided to use. On its own, it doesn't work. It requires this subset and seed to be passed. So, this I had to discover after I wrote the code, executed, said, these things missing. So this was TensorFlow requirement. So these were the four bugs. Okay, when they were sorted, at that point, I didn't need to do anything on the model training. I simply could write this model. Yesterday only I wrote it like this. So this thing, model architecture was, how was the model architecture? Uh, like this. This is how the model architecture was. And that's it. I wrote the model architecture like this, the neural network code written in this way. I overrode Keras's methods because makes it easier to debug. And C, even though debugging didn't come here, the debugging came into play at this fit. Because if I call the default Keras function for training on the data set we are giving, so if I execute it like this, it runs. Okay, it runs fine. The loss is decreasing now. The error is not actually, accuracy is not increasing fast. So there is some other problem. But this works end to end. Data is read and it gets passed through the model. Before there itself was problem because model.fit is internally a complicated thing. And when I did some mistakes here, whether it was categorical or somewhere on this or something, I didn't even know where I got wrong. So that's why the the debuggability of code is actually quite important because it never goes right in the first place. So after doing all this, I got to the place where this thing is actually easy to read and in one line, single line, end-to-end pipeline. So yesterday, which what I was attempting to do, the end-to-end pipeline, it had bugs, and after fixing all of this, only then I have this. Okay. So in model training also, I've done forward pass, error calculation, gradient update, but in reality, reducing of error. This is not happening. This is still remaining. So I will figure it out, but in rest of the things, we have this whole end-to-end pipeline ready. So I think progress is, we can say 60%, 20, 20, 20, and then experimentation and submission. So I would say 60-70% we have actually reached in making progress. This debugging thing, I will try to figure it out. And by the end of the day, we will have this Kaggle submission done.